Okay, let's get to the section 3 and with name the language of physics. Okay, so you know the language of anything, it's something you describe or you study this thing well. So if you, for example, if you study Quran, so the language of Quran is Arabic, you have to study Arabic. And if you study physics, the language of physics is equations, tables, graphs. So whenever you enter physics class, you'll find the teacher is writing equations. You will find your teacher will always make a table, make a graph. So why he's making like this, or why he's writing like this? Because it's the language of physics. It's the language of physics. It's how we describe physics. Okay. So why we use, for example, the tables? If you just make a table like this one, okay, table. This table مثلا consists of distance, time, and velocity. And when the distance was, for example, 1, and time was also 1, so the velocity is 1. And when the time, when the distance was 2, and the time was after 2 seconds, for example, 2 seconds, so the velocity is also 1, because the ratio here, the velocity is equal, V equal d over t, d1 over 1, so equal velocity equal 1, 2 over 2 equal 1, 3 over 3 equal 1. So we always arrange or organize our data in the table. So the purpose or the goal of the tables, of these tables, to organize our data. Okay? Then after you organize your data, you can make a graph with this data. For example, the same table, you can make a graph for the same table. And you can put the distance here in the y-axis. And this is called x-axis. Okay? So you have to write your numbers or write your scale 1, because here in the time scale we have 1, 2, 3, so I'll write here 1, 2, 3, 4, etc. ماشي? And for the time, or for the distance, sorry, so 1, 2, 3, 4, etc. Okay? And I said when the distance was 1, the time also was 1. Or when the time is 1, the distance is 1. So this point is here. And when this one is 2, this one is 2. 2 and 2. Hey, 2, 2, and 2. So they intersected at this point. 3 and 3, they intersect at this point. Okay? And with all of these points, you can draw your graph like this. Okay? And then you can get many information from this graph. Because if you get the slope of this graph, you can get the velocity. Why? Because from the equation, which is velocity is equal distance over time. Okay, that means that the distance is equal velocity times time. I just get the distance, to get the distance equal velocity times time. Okay? And the slope of the graph is always the physical quantity that times the x-axis. So where is the x-axis here? The x-axis is the time. So what the physical quantity is times the x-axis v. So because of that, the slope of this graph is the velocity. Okay? Or if you get the slope at any time, okay, you will get the velocity. How you can get the slope? You know that the slope is equal y2 minus y1 divided x2 minus x1. Let's take these measurements, these two measurements, or these 2 points. So x, or y2, this is y1, and this is y2, and this is x1, and this is x2. So y2 minus 1y, 3 minus 2 over x2 minus x1 also 3 minus 2 equal 1. Okay? So right now, tables for organizing the data, graphs for summarizing and indicate the relation. How you can summarize the data in the graphs? Because you only can know that the relation between the distance and the time, distance and the time, is directly proportional only by seeing this graph, or only by looking to this graph, because it's a straight line like this. And if it was like graph like this, okay, but the graph was like this, so it means what? It means that there is inversely relation between any two physical quantity. Okay, so if the graph was like this, it's inversely, the graph is like this, is directly proportional. What I mean by directly, that means that the distance increase when the time increase. But this one, the physical quantity here will increase if this, will decrease if this one increase. So this is inversely relation, but this one is called directly relation. Okay? And also you can get something called the instantaneous velocity, for example, from this table or from this graph. How we can get it? Instantaneous velocity means the velocity at certain time. For example, the velocity at 4 seconds, or at the second number 4. So how you can get it? You will just draw point like this, and then look at the other, and you find when the time was at the 4th second, the distance was at the 4th meter, or the position was get to the 4th meter. Okay? Okay. So graphs to summarize and indicate the relation. Summarize by looking into the graph and knowing it's directly or inversely, and indicating the relation. You can know it's directly or inversely relationship, or you can know the relation between any two physical quantity. And at the end, this is the equation. Okay, and by the equation you also can describe the relationship, because here if you make this one is constant, so the v and the d is directly proportional, and if you make the distance constant, v and t is inversely proportional. So you can also get or describe the relationship, and also you can predict any velocity that you like. And for imagining imagination, يعني for distance 1000 or 100, and the time was only 2 seconds. So the speed of this car will be 50 meter per second. Okay, this measurement is not in the table, but we can predict it, or we can get it by the equations. Okay, then we get the abbreviation of unit. Okay, I said don't write second, you can write only s. Okay, don't write meter, you can write only m. Okay, m like this. Okay, and then we have something called dimensional analysis and order of magnitude. What the dimensional analysis and how I can benefit from this one. Okay, dimension analysis. If you have, for example, the rule of the velocity, v is equal distance or displacement over time. Okay, and you like to get the unit of the v. How you can get the unit of any physical quantity? You can get it from the rule or from the equation. Distance is what? Distance is measuring the length or the actual path that the object covered. And if this was displacement, because it's displacement, it's the smallest or the shortest straight line between the starting point to the ending point. So it's with number. Okay, and its unit could be meter or could be kilometer, and for the time its unit could be second or a minute or hour. So here we measure the distance with meter, for example, and the time with seconds. So the final unit will be meter, and then we have this fraction, so it's per second. Okay? And also you can check if your answer right or wrong. For example, if you have distance, and for example you say that the distance is equal v over t, and you want to know is it right or wrong. Okay, let's get it by the dimensional analysis. Okay, you know that the v, or the velocity, with meter per second. Okay, or you can write it as like this: meter divided second. And the time, you can write it like this. We have here divided, هنا divided, and then time. Okay, so time is what? Time is second. Okay, and you can remove this division into times by flipping or by get the reciprocal of the next physical quantity, like 1 over second. Okay, and then meter times meter equal meter. Second times second is equal second square. And you know that the measuring unit of the distance is meter, not meter per second square. So that means that this rule is wrong. Okay? So by the dimensional analysis, you can know this rule is wrong or right. Yani, for example, for the d, the right d, you know that the d equal, the right one, d equal v times t. V, velocity, times t, time, equal. Velocity, measuring unit of the velocity, meter per second. And measuring unit of time is second. And second will cancel the second, so the measuring unit will be at meter. And we know that the density, that the distance or the displacement with meter. So this rule is right. Okay? This calls the dimensional analysis. Let's get to the order of the magnitude and how we can benefit from it, or how we can use it. Okay? For example, you're doing a mathematical equation, or you're doing a multiplication or summation like this. Let's say multiplication. So 10 to the power 5. Here we have some 3.04. Okay, times 10 to the power 5, and times 213 times 10 to the power 6. Okay. Before you know the answer, you have to know that the answer should be something here times 10 to the power what? 5 or 6. 5 plus 6 equal 11. So the order of magnitude of the answer should be 11. And if it wasn't 11, so you may doubt about this answer, or you may say that this answer may be not correct. Okay? This is the method of using the order of magnitude to know that your answer is right or wrong. Okay, that was section 3. Let's get quickly to section 1 in chapter 2 to be ended our curriculum for quarter 1, inshallah. Okay, for the next lesson. Okay, this lesson is called displacement, or it's called vector and scalar. It's called displacement, to be honest. Displacement. Okay? At the beginning of the lesson, I said to you that any physical quantity could be what or what? Scalar or vector. Okay? And when it's a scalar, so you will find its description with only magnitude. Okay, and if it was vector, so you will find its description or its number with magnitude plus direction. Okay, like what? Like number one, we can say force. Because if I have this duster, and in order to apply force in this duster, for example 10 Newton, so I apply 10 Newton in this duster in this direction. So it means it requires direction. So the force is example here. Okay, and here we can take time, for example, time. I say the time of this session, for example, is 1 hour. Okay, 1 hour. I didn't mention the direction, so because of that it's a scalar. And here in the force, it's 10 Newton to the north, or 10 Newton forward, or 10 Newton backward. Okay, so to the north, say. Okay, so what also another example we have in scalar and vector? These examples are so important. Here we have distance, and here we have something called displacement. Okay, here we have something called speed, and here we have something called the velocity. Okay, okay, so let's know the difference between distance and displacement and speed and velocity. Okay, I write it just here. Okay, I said to you, okay, if you get from this position, which is called A, then to B, then to C, then to D. Okay, and this one was 10 meter, this one was 5. And I asked you about the distance that you covered from this to D, from A, B, C to D, and the displacement. I always put this arrow at the top of the displacement to mention or to represent that this one is vector. Okay, so when you find the D and at the top of the D this arrow, it means displacement. But if you didn't find this arrow, so it's the distance, the regular distance. Okay, and also I need the speed and the velocity. Okay, I'd say to you that the distance is the actual path that covered by the person. So this person, how he moved. He moved from A to B to C to D. So the real or the actual path that he covered is 10, then 5, then 10. So the distance will be 25 meters, which is 10 plus 5 plus 10. Okay, let's get to the displacement. Displacement is the straight line from the starting point to the ending point, like this. From the starting point, which is the A, to the ending point, which is the D. Starting to ending. Okay, let's get the length of this vector or the length of this displacement. Because this one is 5, so this one is 5. So the displacement is 5. Okay, but it's in which direction? We know that this direction is called what? If you have the direction, here is north, here is south, and here is east, and here is west. Okay, so the direction here is to south, is 5 meters south. And to be honest with you, you won't find south and east and north a lot in your book, because we replace them by signs. What are these signs? North with positive sign, south with negative, east with positive also, and west with negative. So we can remove the south, okay, and only put here -5, okay. Let's get to the speed now. Speed is equal distance over time, and velocity is equal displacement over time, okay. So if I get you and said he covered from A to B in 2 seconds, and from B to C in 2 seconds, and from C to D in 3 seconds, so the total time is equal 2 plus 2 plus 3, okay, means 7. 2 plus 2 plus 3, so the total time is equal 7. Yalla, let's get the speed. Distance, which is 25 divided time is equal 7, so the speed is 25 over 7, and we know that the measuring unit of the speed is meter per second. Why is meter per second? Because the distance was meter and the time was second, and this the fraction is called per, so it's meter per second, okay. Let's get to the velocity, which is displacement divided second or divided time, and we said the displacement was -5. You have to write it as it is without removing or cancelling this minus or this negative sign. Put it as it is, -5, and the time was 7, so the velocity is -5 over 7, also meter per second. Mister, but where is the direction? I said here we represent the direction by negative or positive, so the velocities always have the direction of the displacement. So if the displacement was to the south, so the velocity is to the south, okay. That's fine. So let's take another example, easy example, okay, and let's write it right here, okay. A person moved from A to B to C, okay, and this was 15 and this was 10. Okay, so what's the distance and what's the displacement? Distance is the real or the actual path that the person covered or the car covered, so he get from A to B, then to A, B, C, okay. So the distance is equal 15, which is this distance, plus this distance plus 10 equal 25 meter. And the displacement, okay, for the displacement we said it's the straight line between the starting point to the ending point, and the starting point was A, like this, and ending point was C. So the length of this straight line will be the displacement. How to get the length of this line? Pythagoras theory. Pythagoras theory. How you can get Pythagoras theory? If you have an right angle or triangle have right angle, yani right triangle contain angle 90. So by knowing this side and this side, you can get the other side, which is called the hypotenuse. Means what? Means that the AB, this side, square, plus BC, this side, square, equal, this one is hypotenuse, AC square. AC square. Mister, but I don't like to get the AC square. Okay, you can put the root to remove this square. But you can't only put the root here, you have to put the root here and here. And the root here, okay, the root here with the square cancel each other. So it will be like this. AC is equal, okay, our displacement is equal, AB square, which is this one, plus BC square, okay? Okay, let's get it. So to get the displacement, d equal root ab squared 15 square plus bc squared, this part 10 square, equal the displacement. Okay? Okay, and don't forget this information. If the person moved from the starting point to another point and then get back to the starting point, its displacement equals 0. What I mean by that? If the person here moved from A to B, then to C, then to D, okay, A, B, C, D, and then get back to A, so its displacement in this time is equal 0. And the same for the velocity, because velocity is the displacement over time. When the displacement is 0, and 0 divided any number will be 0. So again, when the person get back to its starting position, so displacement is equal 0, not only the displacement but also the velocity كمان. خلاص? Okay. Let's use the rule and we will be fine, or we will be finished. We will be finished our, inshallah, our lesson or our curriculum. The rule of the velocity. You know that the velocity is equal displacement over time. What if I asked you about the displacement, or if I asked you about the time? Okay, so you have to write this triangle. Okay, the physical quantity is in the numerator. Keep it in the numerator. Physical quantity in the numerator. Keep it in the numerator. And because the displacement in the numerator, put it here in the numerator like this. Okay, and the other physical quantity, put it at the denominator, v times t. So in order to get the t is equal d over v. D displacement over v. And in order to get the v equal d over t. Okay. And in order to get the d displacement equal d equal v times t. V velocity times time. Okay? Okay. But don't forget that. Don't forget that. For example, if the velocity v was 10 meter per second and time was 10 minutes, and I'm asking you about what? I'm asking you about the distance or displacement. Okay? So you would say displacement equal v times t. V is equal 10. This one, hey? And t is equal also 10. And you will say it's equal 100. Okay? So this answer is wrong. Why? Because here you represent the velocity with meter per second. And here we represent the time with minute. You can't do that. You have to unify or make the unit that you use is equal, or the unit you use is only one. When you measure the time with second, here you have to measure the time also here with second. When you find that the speed meter per second, so the speed here have to be meter per second. Okay? So let's convert from meter to second. We know that the minute, from minute to second. We know the minute consists of 60 seconds. So to convert from minute to second, we multiply times 60. Okay? So we have, before getting the displacement, you have to say time in seconds. 10 times 60 equal 600 seconds. Okay? Then get the displacement as you like. Displacement is equal velocity 10 times time, which is 600, equal 6,000 meter. Why it's meter? displacement with meter because the velocity was equal 10 meter per second. And if the velocity was kilometer, so the displacement in this time will be with kilometer. Okay, that's fine. Final question. I'm sorry for graph like this. Okay, and here we have distance or position, and here we have time. Okay, and he moved like this. Okay, from here to here to here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay? So, you have to describe the motion of this car. Okay? The car at the beginning was moving like this. From meter number 0 to meter number 1. Okay? Means from rest to meter number 1, then to meter number 2, then to meter number 3. It get to the meter number 3 after 2 seconds. Okay? So how we can get the velocity? We know that velocity is equal displacement over time. Displacement from 0 to 3, displacement is equal 3. In time 2. 3 over 2, 1.5. Okay? And since it's positive, that means that this car is moving in east direction. Okay? So in this period of time, from 0 to 2, the car is moving towards the east direction. Then from 2 to 4, the car is constant, or the car is fixed at the third position, at the meter number 3. I mean after the 3 seconds, it's still at the third meter. At 4 seconds, still at the 3 meter. 4 seconds and a half, still at 3 meter. But then start to move again, and the displacement increase again. So, if he asked me or what the interval of time, or the time interval that the object was constant at, or the object was at rest at, I say from 2 to 4.5. يعني at rest from 2 to 4.5. How many seconds يعني من 4.5 لحد 2? 4.5 minus 2 equal 2.5. يعني for 2.5 seconds he was at rest, and then increasing its motion again, or increasing its speed again, and then at rest again. At rest from 5 to 6. Okay? So he get to the rest 2 times. The first one, or the first time, from 2 to 4.5. Second one from 5 to 6. And then he get back from the meter number 6, meter number 6, and he get down to the meter number 3. Okay? And if you get the velocity here, from 6 to 3, displacement is equal 8. From 6 to 3, final minus initial. Final, which is 3, minus initial, which is 6, over, he get from this one to this one, okay, in this interval, from 6 to 7, means 1 second, 7 minus 6, 7 minus 6, okay, 3 minus 6 equal 3, 7 minus 6 is equal 1, okay, but sorry, 3 minus 6 is equal negative 3, so the displacement here, not the displacement, the velocity here is negative 3, okay, negative 3. What does it mean to be the velocity with negative 3? That means it's in the opposite direction. Here it was moving not to the east, it was moving to the west. Okay? And that was the end of our curriculum, or our session today. Thank you very much. I hope all of you, inshallah, get the whole success in the next exams. Thank you.